So there are 4 potentiometers. The first one controls the very bottom one and it rotates the whole arm left and right, and the second one controls the second servo motor and it's more of an up and down motion, and the third potentiometer controls the third servo motor and it's again up and down but more for the upper part of the arm. And then for the last one, it controls the last servo motor and it opens up and closes the claw. And here, as you press the button, it counts up all the way up to 9. So I'm going to explain my circuit diagram here just because it's easier to see. So obviously first we connect the positive rail to the 5-volt supply and the negative rail to the ground. And starting with the servo motors have 3 wires coming out of them. The brown one is going to be connected to the negative rail. The one in the middle, the red one, is going to be connected to the positive rail, which is the 5-volt supply. And the orange one to the right is going to be connected to a signal pin, one of those digital pins. And the potentiometers have 3 pins. The one on the left is going to be connected to the ground, and the one in the middle is going to be connected to the analog pin, and the one to the right is going to be connected to the positive rail, the 5-volt supply. And basically what happens with the potentiometers and the servo motors, as you turn the knob, the potentiometer reads a value between 0 to 1023, and then that gets sent to the servo motor, but before the servo motor actually moves according to the value that was sent, it has to convert it to degrees. And for the counter, the push button is connected to the ground, and the other pin is connected to a digital pin as an input. And for the display, each of the pins is connected to a digital pin as an output. And as the user pushes the button, the counter display counts up each time all the way to 9 and then resets to 0. Okay, so now I'm going to explain the code. So the first line is include servo.h, and this just enables us to access the Arduino servo library. And this portion of the code is going to be for servo 1 settings. So first we have servo 1, and this just creates a servo object to control the servo using the library we just added. Then we have constant int servo 1 pot pin equal to A0, and this just assigns the potentiometer to pin analog 0. Then we have constant int servo 1 pin equals 7, and this basically just sends signal to the servo and it's assigned digital pin 7. And then we have int servo 1 value, and this is creating a servo value variable to be used later for rotating the knob. And we basically do the same exact thing for servo number 2, servo number 3, and servo number 4. Inside the void setup, we just attach each servo to the previously assigned servo pin values. So for the first one, we assigned pin 7, so this sends an output to servo on pin 7. And the second one sends an output to servo on pin 10, and then pin 12 and pin 13. Now inside the loop, we use analog read, and this reads the value of the potentiometer pin, which is A0 for this one, analog 0. And this value isn't recorded as an analog voltage, but rather an integer between 0 to 1023. So on this next line, we use the map function to convert the values 0 to 1023 into degrees. So I'm going to be using 0 to 180, but it can be changed to 90 or any other angle value. And basically we do this because the servo doesn't understand the values that the potentiometer uses, and it only understands values of degrees of rotation. So once we do that, we use the write function, and basically this assigns the servo the value that we just calculated with the map function in degrees, and this basically makes the servo move based on the value that was passed previously. And then we do the same thing for the other servos, and this delay function just delays the servo movements by 5 milliseconds, and it helps it get to the desired position and just prevents it from bouncing back and forth. So now I'm going to explain how the 7-segment display counter works. So basically there's 7 segments, A through G, and each pin is responsible for one of the segments. So each of these are going to be connected to a pin, and then we have these two are common cathodes, and that's where our resistors are going to go. So depending on which segments we need to have on, we either have it on or off. So for example, like number 8, we would need all the segments to be on. But let's say for number 1, we wouldn't need A, F, G, E, and D. We would just need B and C. So for the 7-segment display, we declare variables for each segment and assign a pin for each one. And then we use pin mode to declare them as outputs, and we also declare the button pin, which is pin 11, and it's basically an input for the push button. So the conditions for the 7-segment counter work like this. If the digit is not 1 and it's not 4, then segment A will be high, which means it will be displayed. Otherwise, if it is 1 and 4, it wouldn't be displayed, because we don't need that particular segment that was shown in the diagram for those numbers. And then same thing for 5 and 6. If the numbers are 5 and 6, then we wouldn't display them. If they're not 5 and 6, we need that segment for, which is segment B in this case, so it should be displayed, so it would be read as high, so it would be displayed. And it's just the same for all the other segments, and that's the basic idea behind it.